So we have in the last class we have completed the force vibration. Okay, we have find out the differential equation of force vibration and also solve it. Now we will discuss the amplitude resonance. Amplitude resonance. What is resonance? How will get resonance? When the amplitude becomes maximum. Okay, when the amplitude becomes maximum, that is called the resonance. If there are two waves and if the two waves are perpendicular to each other, and at a particular point, a particular frequency, what happens? We get the resonance. That means the amplitude becomes very high at that point. And that is called the resonance. Now, in case of force vibration, what is amplitude resonance? For a particular value of the applied frequency, okay, frequency of the applied force, for a particular value of the frequency of the applied force and natural frequency, the amplitude or displacement amplitude of the force vibration will be maximum. Okay, displacement amplitude of the force vibration becomes maximum. That is called the amplitude resonance. Okay, let's go. In case of forced vibration, for a particular damping, and at a particular frequency of the applied periodic force the displacement amplitude of the forced vibration is maximum. This phenomena is called amplitude resonance. Full stop. Okay. Now, what is the displacement for force vibration? What is the displacement for force vibration? The displacement for the force vibration is x equals to f by root over omega 0 square minus into e to the power I pt minus delta. Okay, this is the displacement for the fourth vibration. Now, which one is the amplitude? Amplitude konta? First term. Here the amplitude A equals to F by root over omega 0 square minus p square A whole square plus 4 k square p square. This is the amplitude. When the amplitude is maximum, when A is maximum, if the denominator is minimum, when the denominator is minimum, then A is maximum. Now, what is the condition for maxima and minima? Mathematics করেছিলেন optimum, condition for optimum. বলো বিষয়টা বলো না, তারপর আমি বলছি। হ্যাঁ, first order differentiation will be 0. Okay, this is the first condition. And if the second order differentiation is negative, then that is maximum, and if it is positive, then it is minimum. Okay, so if this is minimum, that means the differentiation, first order differentiation of this one is 0. Okay, therefore, now the amplitude A is maximum for a particular value of p, for a particular value of p for which the denominator is minimum. Okay, for a particular value of p, the denominator will be minimum, and at that time the A will be maximum. For a particular value of p, for which the denominator is minimum. Okay, therefore dVp of omega 0 square minus p square A whole square plus 4 k square p square equals to 0. Better? Because 0 হবে। Now find out the DDP of this one. Differentiation. Find out the differentiation. দেখো ডিডি করলে কি হবে, এই দুটো পাওয়ার সামনে চলে আসবে ফার্স্ট, or 2 And for this one, minus p square, it is minus 2p omega 0 square minus p square plus 8 k square p equals to 0, or minus 4p omega naught square minus p square plus 8 k square p equals to 0. Or divided by 4p minus omega naught square minus p square plus 8 k square equals to 0. As p not equals to 0, p is the frequency. Okay, p is the frequency of the applied force, so it will not be 0. So you can divide by p. Or omega 0 square plus p square plus 8 k square equals to 0 minus. So 8 k का 2k. Or p square equals to omega 0 square minus 2k square. Okay? Or p equals to root over omega 0 square minus 2k square. P equals to root over omega 0 square minus 2k square. So this is the frequency of the applied force. This is the frequency of the applied force for which A will be maximum. Right? Karon ki amra etake 0 korlam such that it will be minimum. Okay, and when it will be minimum, then A is maximum. That means for this value of P, the amplitude will be maximum. Okay, and you can see that P also depends upon the K. So by the definition we have written, for a particular value of damping and for a particular value of the applied frequency, okay, the amplitude, displacement amplitude becomes maximum. That is called the amplitude resonance. Hence, the cyclic resonant frequency is cyclic, SYCLIC. Cyclic resonant frequency is given by cyclic resonant frequency is given by SR equals to P by 2 pi. P is the resonant frequency. Okay, that is the angular frequency. So the cyclic frequency is FR. So this is equals to P equals to root over omega naught square minus P square by 2 pi. By 2 pi. This is the resonant frequency for which A will be maximum. Okay. This is the cyclic resonant frequency for which A is maximum. Follow? Omega square minus 2k square. Okay. So this is the resonant frequency. So what is the maximum amplitude? How will get the maximum amplitude? A max. If we put the value of P here, right? If we put the CD, then A will be maximum at that point. Therefore, the maximum value of the amplitude is A max equals to F by root over omega 0 square minus P square, omega 0 square minus plus 2k square A whole square plus 4k square into omega 0 square minus 2k square. We put the value of P square from here. Omega 0 square plus 2k square plus 4k square into omega 0 square minus 2k square. So this is equals to F by root over 4k to the power 4. 4k to the power 4 plus 4k square omega naught square 4k square omega naught square minus 8k to the power 4. K to the power 4k to the power 4 or A max equals to F by then 4k square omega naught square over 4k square omega naught square minus 4k to the power 4 or A max equals to F by take 4k to the power 4 4k square common. There is 2k root over omega naught square minus k square. So this is the maximum amplitude of the force vibration. Equation number 4. This is the maximum amplitude of force vibration at resonance frequency. So this is the maximum amplitude of forced vibration at resonant frequency. At resonant frequency. Okay. Now the velocity resonance. Velocity resonance. So here we find out the amplitude resonance. That means the displacement amplitude becomes maximum. Okay. Now for a particular value of the applied frequency, the amplitude of the velocity of the particle. Amplitude of the velocity of the particle becomes maximum. Okay, that is called the velocity resonance. When the amplitude of velocity, displacement amplitude. Now it is the velocity amplitude. Okay, when the amplitude of velocity of the forced vibration, when the amplitude of velocity of the forced vibration under the action of external periodic force is maximum, then the phenomenon is known as velocity resonance. Then the phenomenon is known as velocity resonance. Okay, so for a particular value of the frequency of the applied periodic force now. So stop. In the next paragraph. If the applied periodic force on the particle is F0 sin Pt, F0 e to the power ipt. So it has two components, one is cos Pt and another is sin Pt. So we take F0 sin Pt. Then the solution, or then the displacement of the forced vibration is, x equals to sin Pt minus delta. X equals to f by root over omega naught square minus t square a whole square plus 4k square p square sin Pt minus delta. Now this is the displacement. Okay, due applied force is F0 sin Pt, so here we take the sin term. If the applied force is F0 cos Pt, then we will take cos term here. Okay. So what is the velocity now? How will we get the velocity from here? dx dt. Therefore, the velocity is v equals to dx dt. So this is equals to so Jayanta is constant, t नहीं होगा. Only the differentiation of this one. So it becomes fp by root over omega naught square minus p square a whole square plus 4 k square p square into cos pt minus delta. This is the velocity. Then what is the amplitude? Velocity amplitude. First term. So therefore, the velocity amplitude is v naught equals to fp by root over omega naught square minus p square a whole square plus 4 k square p square. V naught equals to fp by omega 0 square minus p square whole square plus 4 a square p square. Now, when V naught is maximum, if for a particular value of the applied frequency, the frequency of the applied force. Okay, so from here you can see that from equation 3 you can see that when P equals to omega naught, okay, this term is 0. So if it is 0, then V naught is maximum at the time. Only there is the 4k square p square. Okay. Now at P equals to omega naught, the amplitude of velocity or the velocity amplitude V naught is maximum at P equals to omega naught. At P equals to omega naught, the velocity amplitude V naught is maximum. Okay, and Vmax equals to Vmax equals to Fp by it is 0 হয়ে যাবে, then only 2kp Kp cancel, this is equal to F by 2k, or Vmax equals to F by 2k. Our 2k is B by M, so this is equals to F into M by B, as 2k equals to B by M. So this is the maximum velocity. And from here also you can see that as 2k decreases, Vmax increases. 2k is the damping constant. So you can see that as damping constant decreases, the velocity amplitude increases. কারণ damping যত কম হবে তত ভালো velocity maximum পাওয়া যাবে আমাদের. Okay, now give a physical example for this one. P equals to omega naught, then the velocity is maximum. What is the physical example? When P equals to omega naught, then the velocity amplitude is maximum. When the soldiers cross the beach, they don't march on the beach. Why? That is the fourth vibration. Because every bridge has a natural frequency. কারণ দেখেছো ব্রিজের উপর দাঁড়াবে এবং ভারী কোনো গাড়ি যাবে দেখবে ব্রিজটা কাঁপছে, যত ভালো কাঁপবে তত ব্রিজ ভালো মানবে না। That is the natural frequency of the bridge. Now when the soldier march, then what happens? They will give a periodic force. Yeah? They will give the periodic force on the bridge. Periodic force kind of parade করছে. That means after a certain time, all the soldiers give the same force. And the frequency will be, if the frequency P, that is the periodic force, is equal to the omega naught, that is the natural frequency of the beach, then there is a maximum vibration of the beach. Vmax will be increases. Okay, and at that time there is a chance to breakage of the or damage of the beach. So I can don't march on the any bridge on the of the bridge. Okay, और देखो F का की F equals to F by m0. हमारे F is the force. तो actually F force टा so many soldiers is given. और your Vmax is very high at that time. And also, if P equals omega naught, then what's happened? Then they will get the Vmax, maximum velocity. Okay, if there is the maximum velocity, then what's happened? Kinetic energy of the maximum of the bridge, half m Vmax square. Okay, if the kinetic energy is maximum, then there is a chance of damage of the bridge. Okay, so they don't march on the bridge. Okay, so this is the command due to the forced vibration. That is also an example of forced vibration. Okay, so today you have to this one. In the next class, we will discuss the sharpness of resonance.